In this video, I am going to work through showing how to do a linear regression using your TI-84 calculator. Now I'm going to do some of this with the TI-83 because that one shows up better. It's virtual on the screen. Some I will do with document camera on an 84 because there's some cases where that's going to match up more with what you have. So I'm going to bop between the two calculators. When we're doing a linear regression, we have a list of data, and they have to have both an X and a Y on here. So we're comparing two values for each pair. So in here, I'm comparing shoe size to a person's height and saying, is there any connection, any relationship between that? So the first thing we want to do is look at it in the graph, because a scatter plot, is the easiest way really to see patterns. Now, to do a scatter plot on your calculator, once we get it on, we're going to start with this button here that says Stat. Most of what we're going to do are in this Stat menu. So when you click that, you have the options to edit your lists under this one. Calculate is to work with the data, and test is something that you won't do in this class ever. That's something that when you get into doing more statistical analysis, you start looking at some of that test stuff. So we're going to start by editing a set of data, basically putting it in. So we have edit highlighted. We have one edit, so you can just hit enter, or you can just hit 1. Now, I have this in already in my calculator, but I want to show you first, if you have data in your calculator and you want to type over it, I have this third list I don't really need. If you go arrow up to where it has the name of the list, list 1, list 2, list 3, and you hit here list 3, I hit clear. You know, it just says list 3 equals nothing. When I hit enter, it is all gone. And so now we have my just list 1, I have all the shoe sizes in there. List 2, I have the height in inches. So right now, pause the video and type in your lists so that you have that in there. When you're done, we should look something like this. So pause your video. When you're ready, come back and we will continue. So one thing that's important is when you look at these two lists, list 1 and list 2, you notice they both have the same number of numbers in them. You should have down entry 19 should be your last one, and both your list 1, your X's, and your list 2, your Y's. If there's a different number in one of these than the other, the calculator will pop up errors and you have missed something. You've done something wrong. So you need to have a Y with every X and X with every Y. So to look at the scatter plot, we're going to look and let's make this bigger. Right above, very pixelated on mine, right above the Y equals, you see it says stat plot. That is to do graphs with anything that you enter into the stat editor. So to get to that, we will, since that's yellow on mine, we're going to hit, it'll be blue probably on yours. Second, Y equals brings up the stat plots. So there's 3 different plots the calculator can do. We'll just pick any one of them. I'll pick one. First thing I have to do is turn it on. It's turned off right now. It won't graph it. So I turn it on. The type is right here, says is a scatter plot. This also does other statistical plots. We just need a scatter plot. So that's good for us. We want to say, where are your X's? Where are your Y's? It normally comes up with list 1 for your X and list 1 for your Y. If you want to change it, if you look above the numbers 1 through 6, you see L1, L2, L3, L4, so on. So if I wanted to put my X's in list 4, I would then go second 4 and change that to list 4. I want list 1, so I'll change it back to list 1. Finally, for mark, that's your choice. I like using the little squares, but you can mark it with a square, a plus, or a dot. As you saw, there's 3 different plots, so generally if you have 3 sets of data, you could plot one with each mark. When you have your color calculator, you have more options for that. So that's really nice on those newer ones. I don't have one here. So we'll go with that. We're going to now hit y equals. And you see here I have no equations in here to graph, but I have this plot one highlighted. If these are highlighted, it's going to plot data. If you don't have data in there and you have one highlighted, it will give you a dimension error. So that's one that we fixed already for some of them. To graph this, easiest way with statistical data is I'm going to start with this zoom button, and I'm going to go down to option 9, which is zoom stat. That's going to fit the window to match up with the data that I've typed in instead of having to guess what's a good window for that. So if I hit that, you will get this scatter plot. And see, it's kind of a pattern when we look up here. It's kind of looking like it might be a line. Here I have some weirdness going on, especially this point right here. That's coming from this piece of data, 858. This is a pretty small person, so that's kind of making this whole thing look weird. But it does look reasonable to think I could represent that with a line. That's what we're doing with this linear regression. We're saying it's not a perfect line, it's close. So let's see what kind of a line, what kind of an equation we can get for that. Now, if we do that by paper, and if you're taking college statistics, you will get to learn how to do this by hand and do all the calculations to figure this out. We're not going to do it. We're going to let the calculator do it. So here's where I'm going to switch over to my other calculator. I need this one up and put this one away for now. Turn this one on. So under stat, I still have all that data. I've typed that in here. But we're going to go back to stat. And instead of doing edit, we're going to go over here where it says calculate and look at your options. So this has a lot of options. So 1 variable statistics, 2 variable statistics. If you just want to find things like mean, median, mode, 5 number summary, you would go to do either 1 variable statistics on just one column or 2 to do on a pair of them. Median, med is another form of a linear regression. It gives us a similar line, but we're going to focus on the linear regression line. But you notice quad regression, we'll do a quadratic equation. We'll do a cubic equation, a quartic equation. So there's other regressions you can do. There's another linear. You notice this one is ax plus b. This is a plus bx. They'll give you the same lines. It's just what do they call a and what do they call b. Then this is for logarithms and exponential functions and power functions. So you got a lot of logistic. Sinusoidal, for all those that remember sine, you can put in data and see, does a sine equation fit it well? So we're going to go back up to option 4, which is the linear regression. When I hit enter, it gives me the wizard, okay? It says, where is your, again, like with the graph, where is your X data? My X data is in list 1, my Y data is in list 2. I don't need to change those. My frequency list I will not use when we're doing an algebra. This is more in statistics where you have a frequency distribution, where when you have repeated pairs of numbers, you type it in once and then tell you how many times you got that pair in there. We're not doing that, so we can ignore that. So we'll just enter, enter, enter. Now here's what's nice. To store the regression equation. So you don't have to write it all out and then type it back in. If you want to graph it according to your data, you can you're going to use the alpha button. So when we use alpha, we've talked about that before for you're using graphing. But if you come over to the trace button, that brings up a list of the y variables. So I'm going to hit enter here for y1 and say I'm going to store my regression equation in memory for y1. And then I can go down and calculate and just hit enter. And this shows me it's an equation in the form y equals ax plus b. So a is 1.949 and b is 49.185. So my equation will finally be, let me grab my tablet so I can write that down. I forgot to turn it on. Sorry about that. Oh, and it took it off the screen, so I don't see it anymore. So I will do it with this calculator. So I can still see it, and I don't have to remember it. On, stat, calculate, linear regression, same step. This doesn't give you the wizard, so it assumes you use 1 and 2 on there. There's ways to change that on this calculator. You don't need to know that because you have the newer calculator. My equation is y equals 1.949x plus 49.185. So this would be my slope. This is my y-intercept. We're generally going to call this y hat because this is our prediction equation. It's not the actual equation to go through all of that data because they're not a nice one. But it's the line that's a good line of fit, we think. Now to see how good that line of fit is, I did not do it the right way. So I will go back to this other one. Because this other one is where I stored it. So when I hit y equals on this calculator, you notice in y1 I have my equation with all of the decimal points that I didn't keep. Now when I hit the graph button, oh, I can't do that with the mouse, do that with the calculator. This is my line of fit. This is the best line that the calculator can calculate to represent this data. This is what we're doing when we find linear regression. Now, to find out, we'll do a little bit more. We can say, how good of the line is that? We can eyeball this and say, well, about half the dots are above the line, about half the dots are below the line. It looks pretty reasonable. It's following the same pattern. But we can also do some diagnostics with this and get that correlation coefficient. So I'm going to have you, if you hit the mode button, and again, I got to do it on the calculator, not with the mouse. That's why I like the other calculator better. But it doesn't have this. It's a different way to get to this as well. This is where you start, but we're going to just keep arrowing down. Color ones, I think it fits all on one screen, but come down to stat diagnostics. If we turn that on, and now we're going to do our regression again. So we'll go stat, calculate, 4 for linear regression. Come down to calculate. I don't need to store my equation because it's still the same equation. But now this gives you your r squared value and your r value. R is a correlation coefficient. The closer this is to 0, the worse the line will actually fit the data. A good line is going to get close to 1 or negative 1. If it's a positive slope, positive correlation, this will get close to 1. Negative slope, a negative correlation, it will go close to negative 1. This is a correlation of 0.79, about 0.8. So it's not a great fit, but it's not too bad. There's a lot worse ones out there. But that's how you find that correlation coefficient when you get the R squared value. So, and again, you want to find out more about those? Take statistics. But this is how you're going to use your calculator to do a linear regression.